Welcome to the 2014 workshop webinar for the Division C trial event Hydrogeology. Hydrogeology is sponsored by the Groundwater Foundation with additional support from the Nebraska Department of Environmental Quality, Science Olympiad, J.A. Woollum Foundation, the Nebraska Environmental Trust, Casey, and Olson Associates. If you have any questions at the end of this webinar, please email hydro@groundwater.org. This workshop will focus on why hydrogeology, why is this subject important and why should your students be participating in it, and how can you successfully prepare yourself and your students to compete in hydrogeology. We'll go over updates to the rules from last year's trial event, as well as a detailed explanation of the event and all resources that are available to you currently. The Groundwater Foundation is the sponsor of hydrogeology. At the Groundwater Foundation, our mission is to educate people and inspire action to ensure sustainable, clean groundwater for future generations. You can see in the photo a picture of two students participating in the event Awesome Aquifers, which is a Division B event. This was the first event the Groundwater Foundation did with Science Olympiad. Hydrogeology will be the second. Hydrogeology is the study of groundwater. It also happens to be the new Science Olympiad Division C trial event incorporating groundwater computer modeling. This is the second year hydrogeology will be trialed. The Groundwater Foundation came up with the idea for hydrogeology based off of Awesome Aquifers. We wanted to go from the hands-on model of Awesome Aquifers to something that would be more applicable to high school students that would help prepare them for ultimately college and the real world. And in this day and age, that led to computer modeling or groundwater computer modeling. So why do we think hydrogeology is important? It allows students to visualize a resource, groundwater, that they cannot see in everyday life. And again, as I said, computer modeling has wide applications in many fields, not just groundwater, so it can really help prepare students for whatever field they would want to go into. Some other facts about groundwater: over 95% of freshwater resources in the United States come from groundwater. 50% of people in the United States get their drinking water from groundwater. And a recent study found that the High Plains Aquifer of Kansas will be 69% depleted by the year 2060 at current pumping rates. Looking back at last year's Science Olympiad tournaments, hydrogeology was run at 2 regional tournaments, 6 state tournaments, and the national tournament. Regional tournaments were only located in Nebraska, but state tournaments included Maryland, Indiana, Ohio, Nebraska, Washington, and Southern California. Most of the feedback we received was very positive, with some good constructive criticism from the students that participated in the event. Some of the student feedback from last year: 95.2% of students learned something new about groundwater from hydrogeology. 76% of students learned something new about computer modeling from hydrogeology. And 20.9% of students said they are more likely to pursue a STEM career after completing hydrogeology. We were especially excited about this last statistic because most students participating in Science Olympiad already are focused on the STEM field. But hydrogeology definitely increased their pursuit of getting a STEM career. Some fun quotes from students: "I did not realize how essential groundwater is until this event. It's a really fun, unique, and intriguing event, very well written and is cool. I enjoy the computer modeling and that you had to think about your answers and not just regurgitate formulas. The Hydrogeology Challenge was a fun, interactive method through which we learned various calculations regarding groundwater." So a little bit more about hydrogeology. This is a 3-part event. Part 1 consists of a written test. Part 2 involves running the model. And Part 3 is the application part where you're actually applying the model output to real-life situations. It's important to note that the rules for hydrogeology can be found online. They are online both at groundwater.org and on the Science Olympiad website underneath the trial events. If you are an event supervisor running hydrogeology, you will require a computer or tablet with access to the internet for each team, as well as writing utensils. Students are allowed to bring calculators, protractors, and one 8.5-inch by 11-inch note sheet. However, if you do not have access to computers or the internet, that is not a problem. There is a paper version of the Hydrogeology Challenge, which is our groundwater computer model. This paper version requires rulers and colored pencils. If you are interested in running the paper version of hydrogeology, you need to contact hydro@groundwater.org. So the basics of the competition. Students can work in teams of 2, and they have 50 minutes to complete all 3 parts of the event. They can complete the 3 parts in any order that they choose, so they are given all 3 parts at the beginning. And then the event setup is very simple. Generally, you'll be in a computer lab, and you'll do 2 chairs per 1 computer so that students can work together on the computer. The model URL will be pulled up on the computer or tablet, and then you're ready to go. So a little bit more in depth about the different parts of the event. As I said, part 1 is a written test. It is 25% of the total score. The written test must include at least 1 question from each of the following concepts. These include the fundamentals of groundwater and hydrogeology, surface groundwater interactions, the relation of groundwater flow to geologic structure, the management of contaminated groundwater. These questions can be multiple choice, true or false, fill in the blank, or short answer. So just to prepare a little bit for part 1, we're going to go over just some groundwater basics, known as Groundwater 101. Over 70% of the Earth's surface is covered in water, and of that water, only 1% is readily available for human use. Of that 1% of readily available water, 99% comes from groundwater. So what is groundwater? Well, groundwater is the water that fills the spaces between soil particles and fractured rock beneath the Earth's surface. As you can see in this image, we've labeled groundwater with the light blue. At the top of groundwater, between the saturated zone and the unsaturated zone, we have the water table. The water table is a very important value for hydrogeology. You can also see that there is a groundwater surface water connection, and that water can actually travel between a surface water body and groundwater. So how does groundwater move? Well, in natural conditions, groundwater follows the laws of gravity just like everything else, and it likes to move from areas of higher water table elevation to areas of lower water table elevation, which you can see by the arrows in this photo. A couple of terms that are important to know when getting prepared for hydrogeology. The first is hydraulic conductivity. Now, hydraulic conductivity is generally defined by the letter K, and it describes the ease with which water can move through pore spaces or fractures. It's related to the permeability of a rock or sediment. I generally like to think of it in the terms of electricity, where if you have a type of metal that's very conductive, electricity is going to easily flow through that metal. So in the case of hydraulic conductivity, a soil that has a very high hydraulic conductivity is very conductive of water. So that would be something like gravel that you can see in the chart, which has a conductivity on average of 241.2. However, something that's not very conductive, that water can't move through very easily, would be clay, which has a very low conductivity of 0.01. Now, the conductivity does depend on the gradient, permeability, and the level of saturation. The differences between a high permeability and a low permeability. A high permeability, you have pore spaces are connected to one another, allowing water to flow freely. Again, a good example, this is gravel. For low permeability, pore spaces are isolated and water becomes trapped. And again, a good example is clay. Porosity is the amount of empty space within a given material. This is measured generally as a percentage. For soil and rock, this empty space exists between grains of minerals. As you can see in the photo, we have pictures of both permeable gravel and impermeable gravel. And you can just see how water can flow easily when the gravel is not connected, but when the gravel is connected, those pore spaces are trapping the water, and it's impermeable, but it still has the same level of porosity and can still hold the same amount of water. So this map is just a very general sources of groundwater contamination map. As you can see, there are many, many places groundwater contamination can come from. Some of the big ones, we can see there is a feedlot where we have manure that's perhaps putting nitrates into our groundwater. And along with that feedlot, there's a farm where we have lots of pesticides and fertilizers. Our power plants produce the airborne sulfur and nitrogen compounds, which then can be rained back down as acid rain, which gets into our surface water and our groundwater. There's always landfills, urban runoff, pollution from automobiles, gas stations. There's just a whole slew of different places groundwater contamination can come from. These are all things that students will learn about and study while they're preparing for hydrogeology. Now that we've covered the basics of Part 1 of hydrogeology, I'll talk a little bit about Part 2. In Part 2, students run the Hydrogeology Challenge for a scenario selected by the event supervisor for 3 wells in static conditions. Static conditions here just means natural conditions. There's no human influence, no wells are pumping water, and there hasn't been an introduction of any pollutants. Part 2 is 25% of the total score. It's also the easiest part for event supervisors to grade because students submit their answers online and the computer grades it for you. So what is the Hydrogeology Challenge? Well, the Hydrogeology Challenge is the computer model that the event hydrogeology uses. It is a learning tool that uses basic groundwater modeling concepts such as flow direction, gradient, and horizontal velocity. It uses simple calculations and simple assumptions to make modeling groundwater fun and easy for students during a Science Olympiad tournament. To get started running the Hydrogeology Challenge and beginning groundwater modeling, there are really 3 steps that are important to go through. Step 1 is knowing the basics. What is groundwater? How does groundwater move? What information is needed in order to model the movement of groundwater? We've covered a lot of these questions already in this webinar, which leads us to step 2, know your model. It is important to understand what the model is telling you and to know what assumptions are made in the model. Once you understand those assumptions and you understand how your model runs, that brings you to step 3, which is running the model and ultimately interpreting the output of that model. So, step 1, what information is needed in order to model the movement of groundwater? Well, in our case, we need to know flow direction, gradient, and horizontal velocity. So in order to determine flow direction and gradient, we need to have at the very minimum 3 wells. So the Hydrogeology Challenge will always have students select 3 wells. The reason for this is because it gives them a plane to look at, and we're actually able to determine the flow direction from that plane. You're also going to need the water table elevation of each well because that's how we can determine the gradient. Same with the distance between the wells. And so with that information, we can determine flow direction and gradient. Horizontal velocity is a little bit more complicated. We need everything listed above for flow direction and gradient, but in addition to that, we also need the hydraulic conductivity of the soil and the soil porosity. So now let's get to know a little bit more about the Hydrogeology Challenge. The Hydrogeology Challenge can be found online at http://groundwater.behere.net. It is freely available, and there are a couple of practice exams up there that students can run through to practice running the Hydrogeology Challenge before they actually get to a tournament. It is important to know the assumptions of the hydrogeology challenge in order to correctly interpret any output the hydrogeology challenge might give you. So here we have two images. On the left is the model and on the right is reality. And this is to demonstrate one of the assumptions the hydrogeology challenge makes. The hydrogeology challenge assumes that when a well is pumping water, that it completely changes the direction of the flow of groundwater. However, in reality, the well would really only impact a small area very close to the well when it comes to the flow direction change, as you can see by these pictures. Another assumption the hydrogeology challenge makes is that it assumes a constant gradient between the drawdown of the well or the cone of depression and the surrounding area. However, in reality, this is actually going to look a lot more like a steeper gradient closer to the well, and then the gradient will actually become less the farther away from the well you go. And then another assumption is that in our model we used very simplified geology. Each layer is assumed to have a uniform conductivity and porosity. It also assumes that groundwater moves through the layer of highest conductivity only. So for example, if you have a layer of gravel and a layer of clay, the model is going to assume that the groundwater is going to move through the layer that is easiest to move through, which would be the gravel. However, in reality, as you can see by this chart, our geology is a lot more complex. You can see the hydraulic conductivity, or K, is listed off on the right in meters per second, and you can see that all the geology has a range of K values, and it's not necessarily uniform throughout an aquifer. So that's a little bit of a change between the model and reality. So now that we know steps 1 and step 2, we know some of the basics and we understand some of the assumptions that our model is making, we're ready to begin running the model. Again, the Hydrogeology Challenge is located online at groundwater.behere.net so that you can practice using the model before a tournament. I highly recommend checking out the event guide practice exam scenario. There is a practice exam that correlates with this scenario in the event guide that is available both on the Groundwater Foundation's website and on the Science Olympiad website. On the Science Olympiad website, it's available underneath the Event Supervisor tab. This is a screenshot of what a basic scenario will look like. This is a screenshot of the event guide practice exam scenario. As you can see, each scenario requires you to choose 3 wells. In this case, wells A, C, and B were chosen. And then you will work through calculating the flow direction, the gradient, and the horizontal velocity of groundwater. One of the nice features of the Hydrogeology Challenge is all of the data is given to you in the scenario. It's given to you in the blue rectangular box that is by the well. The wells are represented by the blue circle letters. So if we look at well A, we can see the blue rectangular box has the letters G, S, and P in them. G stands for the ground elevation. S stands for the water table elevation in static conditions. And P stands for the water table elevation in pumping conditions. You can also click the top right corner of the blue rectangular box, and that will expand the box into our geology table, which lists off all the different soil types below the surface. So in this case, from 0 to 25 feet below the surface, we have a layer of clay, which has a hydraulic conductivity of 0.01 and a porosity of 42%. When running the Hydrogeology Challenge for the first time, you might want to look at the reality check. The reality check is available for flow direction, gradient, and horizontal velocity. You can open it by clicking on the blue checkmark circle box, and each reality check just gives a basic explanation of what you are calculating in that section of the model and the assumption that the model makes. Also, when you're practicing, we have what we call the check answer and show solution buttons. The check answer button, if you click on that, will turn all of your correct answers green and all your incorrect answers red. This is a great way when you're practicing to learn where you're doing things right and where you're doing things wrong. If you're still struggling to figure out a correct answer when you're practicing, you can click the Show Solution button and it'll actually tell you what the correct answer is off to the right, so that you can keep practicing and preparing for the tournament. So now that we've gone over part 2, I'm going to cover in more detail part 3. In part 3, the event supervisor provides a set of circumstances for which the students are required to evaluate the risk of contamination to wells in the Hydrogeology Challenge scenario, explain any and all assumptions that were made in their analysis, and complete a remediation techniques table. This is worth 50% of the total score, and it is the most complex portion of the event, but resources will be made available and currently are available to make it easy for even non-experts to write this portion of the event as event supervisors, and to make it easy for students to know what to study and how to prepare for the event. So in part 3, the first part is really focusing on a set of circumstances. These set of circumstances must include non-static conditions, which means now we have at least one well is pumping water in our scenario. They must include a pollutant, which can be taken from the contaminant table, which I'll talk a little bit more about later, and a pollution source, which is located at one well. The set of circumstances may include different well types, different well uses, or basically any other information the event supervisor deems relevant to the scenario in order to paint the fullest picture of what they're trying to get at in their scenario. So now let's take a look at a sample set of circumstances. In this case, the situation is the small community of event guide practice exam has experienced an underground storage tank leak near well E. Due to the leak, BTEX has contaminated the groundwater of well E. Residents are now looking to your team to determine which wells are at risk of contamination and what options the community has for remediation of their groundwater. Some of the facts: BTEX, the pollutant, was found at well E. Residents are currently pumping water from wells A, B, C, D, and G, and wells E and F are not currently pumping water. This sample set of circumstances is actually taken from the event guide, which is available online, and the event guide practice exam scenario can be found online as well at groundwater.behere.net. Once the students have been given their set of circumstances, they need to manipulate the hydrogeology challenge in order to determine which wells are at risk of becoming polluted and approximately how long until that contamination may occur. And then finally, they'll be required to fill out a remediation techniques table. This is an example of a remediation techniques table. As you can see on the top, it lists off the remediation technique, the definition, whether the technique is in situ, which means done underground, or ex situ, meaning that the groundwater is pumped up from the ground, the type of treatment, if it's biological, physical, or chemical, the cost of the treatment, low, medium, or high, and if the treatment is even applicable to the given pollutant in the scenario. In this case, there are 4 remediation techniques that students need to be able to define, and they are air stripping, phytoremediation, activated carbon treatment, and bioremediation. Additional questions that can be asked in Part 3. Students will use the results from the Hydrogeology Challenge and Remediation Techniques table to answer questions about the scenario. And these questions can be multiple choice, true or false, fill in the blank, or short answer. The Contaminant Table is a resource that is available to both event supervisors and students and coaches. It lists off every pollutant that might show up in the hydrogeology event. It also color codes the pollutants according to what tournament level they might show up at. So regional is red, state is blue, nationals is green. These colors are cumulative, so when you get to state, you will also have to know all of the regionals or red colors, and when you get to nationals, you need to know red, blues, and greens, or basically the whole chart. This chart lists off the category of the pollutant, definition of the pollutant, as well as possible sources that the pollutant could come from. Another resource available in the event guide is the remediation table. This remediation table lists off just some of the most popular groundwater remediation techniques, their definition, their type, the types of pollutants they remediate, as well as their basic cost, low, medium, or high. This table is not all-inclusive. It does not contain all of the remediation techniques that are out there. Event supervisors are not limited to this table, and thus students should study techniques beyond those just listed in this table. If you look at the event guide, there are resources listed that are available for students to study and for event supervisors to look at when preparing for this portion of the event. So the Hydrogeology event guide is currently available on the Groundwater Foundation's website and on the Science Olympiad website. This guide is designed for students, for coaches, and for event supervisors. It has lots of helpful tips for preparation, as well as a complete practice exam, a sample score sheet, and a lot of additional resources. This is really your go-to when you are preparing for hydrogeology. The first thing you want to do is go and download this event guide and read through it and learn about the event. If you are a coach, you might want to give the practice exam to your students and have them run through it just as a trial. And then you can use the practice exam to create your own practice exams for your students if you like. But this is just a really good place to start, and I would highly recommend everyone looking at it who is involved in hydrogeology. So finally, scoring. Highest total score wins. Again, part 1 is 25%, part 2 is 25%, and part 3 is 50%. There are a couple of tiebreakers. The first tiebreaker is the highest score in part 3. And the second tiebreaker is the highest score on pre-selected questions from part 1. All additional resources are currently located at www.groundwater.org/so.html. There are many new resources for the fall of 2014. They include this workshop video, a hydrogeology challenge walkthrough video, which walks you through the basics of how to run the hydrogeology challenge, as well as the updated event guide, which is really designed to make running and participating in hydrogeology easy for everyone. Thank you for listening to the 2014 Hydrogeology webinar. Again, if you have any questions, please feel free to contact the Groundwater Foundation at hydro@groundwater.org or call us at 402-434-2740. Thank you.